All right, I got my wingman back with me today.
Holler!
All right, so we're going to do function notation.
4.2, function notation. What does it involve?
All right, well, this is good old eighth grade math. We have a nice linear y equals mx plus b. This is a linear function. It forms a straight line. But we're going to up the ante this year, and we're going to kind of get rid of this little baby x and y, and we're going to start writing them in the way you're going to see them in calculus.
So that is going to be known as function notation. So today, instead of getting into an example, we're going to describe the example to you. Y equals 3x plus 2. The letter y is going to stand for a function of its opposite variable. In this case, a y is a function of x. So we're actually going to use the term function notation. What does function start with? The letter f. So we're going to write f. And when we see the word of, we open up a parentheses. We're going to say f of a valued variable, in this case x. So what this is stating is that the function is relating the variable x. So f of x is equivalent to 3x plus 2 is the same thing as saying y equals 3x plus 2. They're identical. They mean the same thing. It's just a different notation, a different way to write it.
Yeah, when I was in high school, I didn't understand it at first either, and this is all I did. Okay, every time I see a y, I'm just going to write f of x. And I didn't really get it till I got to calculus. And in calculus, you often have 4 and 5 graphs drawn on one graph. And it's easier to call this f of x, and then this one g of x, and then this one h of x, so I don't have to write the equations all over the picture.
So if we had a picture like that, we wouldn't just necessarily write y equals, y equals, y equals. And you should understand that they're different graphs. That's why Ms. Trulin just put f of x, g of x, h of x, because they're all different functions.
All right, so we're going to work up to that. But today, all you have to realize is the independent variable is x, and our function depends on what we put in for x.
So we're going to get into these two terms, independent variable, meaning an input, and dependent variable, meaning an output. We related in a past video that if you put a quarter into a gumball machine, your output, or what you get from it, is the gumball. So the input would be the quarter, the output would be the gumball. That's just like saying in this function notation, I'm going to put a value in for x and get out a value y.
All right, so all they're going to ask you to do is they're going to give you some examples. So let's just jot down some examples right now. And the first thing they're going to do is they're going to give you y equals x squared minus 9, and they're going to ask you to write this in function notation.
So if we were asked to write this in function notation, once again, replace your y's with this new term f of x. So we're going to write f of x right underneath the y and keep everything else the same. So the function really is x squared minus 9. So we're just going to rewrite that.
Yeah, that's it, people. It's not that hard. Sometimes you could see it other ways, so we're just going to give you ways we could see it. So, Mr. Rood, give me another function.
Another function. Let's go with y equals the absolute value of x plus 1, and then subtract 9.
All right, so there's another way you could do it. Sometimes they write this as f dot dot.
This will be used in IB, if you transition to IB, or in calculus and statistics, which are at the AP level. So upper level mathematics, whether you're at Pearson or whether you're taking it in college.
For the most part, we really like this one. Well, I really like this
No,
one.
I
Right?
do too. That's my favorite. That's
But
my favorite.
just be aware that different publishers use different notation, so you could see it this way. And there's a third way you could actually see it also. And let's do, I'm going to be wimpy and just do y equals 2x minus 8. And you could use it as mapping notation.
Oh, mapping. That's like the arrow, right? The arrow.
Yeah, f maps on to 2x minus 8.
So everyone can see that in example 1, we replace the y with an f of x. In example 2, we replace the y with an f colon, or dot dot. And then in example 3, we did the mapping. We replaced the y with the f and the arrow. Just 3 different ways in which we can write the same function.
All right. So, that being said, now let's get on to even easier examples. So let's say example 4 says something like find f of 4 when f of x equals 3x squared minus 2.
So what this question is really stating is when they say find f of 4, they're talking about this term input and output. If I input 4 into the function for the value x, because remember, f of x was the notation, so if I wrote f of 4, that means we're plugging in the 4 for x's. What comes out of it? So the output is going to be our results. The output will be our results.
All right, so I'm just going to put a 4 in every time I see an x.
So real simply, we would write 3, then we would write 4 squared minus 2. So let's change the color so we keep it uniform. All right, so in this case, really simple, what would we do first to solve? Would we do the 3 times 4 or the 4 squared?
Order of operations, we're going to do the 4 squared. And that gives us 48. I mean, this should all be easy to you guys. And this is just saying when I put a 4 into my function, my input of 4 gives me an output of 46.
And you should also realize that if I have an x value and a y value, that I can label this as an ordered pair. So relating this to the Cartesian plane coordinate system, this is really 4 comma 46, which once again means the x value moving to the right 4 would be the input, and the y value moving up to 46 would be the output.
So there's all different ways, x and y, f, x and function x, input, output, independent variable, dependent variable, they all mean the same thing.
Okay, so let's move. So let's go to another example. Here we have the graph of a function k, so we're just calling it k for now.
I want to review, and it's a function because if we drop that straight line.
Anyone got it? What test is it? What test is it? The vertical line test. As we move or slide this across, you're realizing it's only touching the graph once. If it touches it once, we are called a function. If it touches it more than once, we are not a function.
All right, so it's function k. K for Casey and Katie and anybody else out there with a K in their name.
So for part A, we see it says find k of negative 1. Recall and remember, whenever you have a number next to the letter, in the past examples we used f of x, so f of 1, f of 2. In this example, we're using k of something. Okay, you're going to take this negative 1 in this example and plug it in, that's the input, and find out what is our output. So we're finding our y value in this case, according to the Cartesian plane drawn.
All right, so input means x, so I'm going to go down here to my x-axis, and I'm going to go over to negative 1.
And I'm going to go up on my graph until it touches, which is at 2. And I'm going to realize that my output is the value 2.
Ready? So, watch this. Hey! We popped the balloon.
That's awesome.
And we got 2 as an answer. All right, let's pop the balloon. Let's go. K is 2.
So we're just going to let you try these. So take a second. Go over to 2. Find your output. And did you get? 5!
Hey.
Winner, winner, winner.
Chicken dinner.
We're on part C, real fast. If it says k, find k of a half. Is a fraction going to screw you up? Is it going to be difficult? I don't think so. All we have to do, move over on the x-axis, half unit, And you should be getting
Really, you should be getting it's a dull needle.
3. Who got 3? Who got 3?
All right. K of -2. I'm going to go over to -2 on the x-axis. I'm going to look up, and the answer is 5.
And the last one, find k of x equal to 4. This one looks a little different.
All right, so
How would we do this, Miss Trulin, if we had a function that said k of x equals 4? It doesn't say k of 4.
right, we would have normally gone here if the 4 was there. But this is saying, where does the y value equal 4? We can do it. So the y value equals 4 right here.
So where do we have a dot? Because the dots represent a real point on this graph called k.
All right, so we actually have 3 answers here. One of them is really obvious.
Who's got it? That's right. It is 4.
It is 4. And then the other 2 are not so obvious, but these would be answers, and we never ever really estimate, but I just kind of I should have actually done.
Oh, wait. We had a mistake. That wasn't 4. That was the output of 4. That was really the x value of 0, Miss Trulin. 0.
Oh, 0.
Remember,
so when
we're
I put
talking about
a
x's.
0 in, I get a 4 back.
There's
Because
one
when I put a
answer.
0 and a 4 back. And it looks to be about when I put a 1.5 in. Whoops. I get a 4 back. And it looks like when I put a -1.5 in, I get a 4 back.
So really,
Whoops.
this
Boy, I
problem,
can't write.
This problem wasn't too tedious. It wasn't too difficult. But you just have to understand the difference between output, input, and what the question is asking. We hope you enjoyed our lesson.
Bye.